Hello everyone. Today, let us explore one of the most practical tools in Android application security testing, Frida, and how it helps us bypass SSL pinning. We'll also discuss an even simpler tool built on top of Frida called Objection. Many mobile apps use encryption to protect data when it's sent over the internet. One important technique they use is SSL pinning. As security testers, our job is to make sure the data is really secure. But SSL pinning can get in the way when we try to intercept traffic using tools like Burp Suite. That's where Frida and Objection help. Let's break it down. When an app connects to a server, it checks the server certificate to ensure it's trusted. This is how secure websites work too. But with SSL pinning, the app doesn't just trust any valid certificate. It's looking for a specific one that it already knows. If it doesn't find the exact match, it blocks the connection. And that's great for preventing man-in-the-middle attacks. But a problem if you're trying to inspect or test the app's behavior. In penetration testing, we need to see what data the app is sending or receiving. For that, we usually set up a proxy like Burp Suite. Without bypassing SSL pinning, the app refuses to connect through the proxy, which means we can't see anything. So, to continue with our testing, we bypass SSL pinning temporarily and legally just for analysis. Frida is a powerful toolkit used for dynamic code injection. It lets you attach to a running app and modify its behavior on the fly without changing the original APK. You can think of it like a remote control for the app's brain. Using Frida, we can tell the app to skip its usual SSL checks and trust all certificates. Now, how does Frida work in the background? Frida uses small JavaScript snippets called hooks. These hooks are injected into the app while it is running. Once injected, they override specific functions in the app, like the ones responsible for SSL certificate validation. For example, when the app tries to verify the server certificate, the Frida script can intercept that action and say, yes, this is valid, even if it's not. This trick makes the app behave like SSL pinning is not even there. And that lets us use tools like Burp to monitor and analyze the traffic. Now, here is the fun part, Objection. Objection is a tool that runs on top of Frida and makes it super easy to bypass SSL pinning. You don't have to write any Frida code manually. It's like a command line assistant for app hacking. Once you install Objection and connect it to your test device, you just run a few commands and boom, SSL pinning is disabled. No need to modify the app, no need to recompile, just point and shoot. Here's a general workflow. Install the app on a rooted or emulator Android device. Set up your Burp Suite and configure the device to use its proxy. Connect your device to your computer. Launch the app and then use this objection command. Objection-G, the app package name, explore. Once you're inside the objection shell, run Android SSL pinning disable. That's it. Now you can open Burp Suite and see the app's traffic. When you run that command, Objection communicates with Frida. Frida in turn injects a predefined script into the app. That script hooks into the SSL verification functions and overrides them, telling the app that every certificate is trusted. You don't see the script, but it's there, working silently in the background. This saves you from writing complex code or digging into Android internals. It's like having a personal assistant who handles the messy part of hacking. Now, SSL pinning bypass using Frida or Objection is powerful, but not always successful. Here are some challenges. Some apps detect Frida or rooted environments and crash. Others use native code for SSL checks instead of Java and to require more advanced hooking. Anti-debugging or tamper detection mechanisms might block injection. But for most beginner and intermediate testing scenarios, Objection and Frida work very well. A quick but important reminder. Always have permission before testing any app. Never use these techniques on live apps without proper legal scope. These tools are meant to improve security, not break it. And if you are a developer, knowing how Frida works can help you build apps that are harder to bypass. To summarize, SSL pinning is a security measure, but it can block security testing. Frida allows us to bypass it by injecting code that overrides certificate checks. Objection makes this process easy with just a few commands. Understanding these tools helps both testers and developers build and secure better apps. So this is what SSL pinning and Frida and Objection is all about. Now, when you run the command, Objection communicates with Frida. And Frida in turn injects a predefined script into the app. That script hooks into the SSL verification functions and overrides them, telling the app that every certificate is trusted. You don't see the script, but it's there, working silently in the background. This saves us from writing complex code or digging into Android internals. It's like having a personal assistant who handles the messy part of hacking. So thank you for your time and attention, and I hope this session has given you a practical understanding of how Frida and Objection can be used for SSL pinning bypass. So until we meet the next time, stay safe.